Okay, in this video we're going to be working a little bit more with radicals. I just want to review a couple of things before I show you how to do the FOIL method with radicals. So I'm taking two things we've learned about. We know how to do the FOIL method, and we know about radicals now, so I just want to combine those two. Just to review a little bit, radical 5 plus radical 5 is, you can add radicals as long as they're exactly the same radical. So in this case you're getting 1 radical 5 plus 1 radical 5 is 2 radical 5. They've got to be the same if you're going to try to add them. If you try to take radical 5 plus radical 3, you can't add them together because they're not like radicals, so there is no other answer other than just say radical 5 plus radical 3. So you can't add them unless they're exactly the same radical. You can multiply anything together. So radical 5 times radical 5 equals radical 25, or the square root of 25, which is 5. So when they're the same number and you're taking the square root of both, you're just going to get that number. If that had been square root of 6 times square root of 6, you would have gotten square root of 36, which is 6. So they're sort of squaring it and square rooting undo each other. So it's the same number, you just get that number there. So you can multiply them together. Even if they're not the same, you can still multiply them together. Square root of 5 times the square root of 20 is the square root of 100. You can just multiply them together, and we know that the square root of 100 is 10. So square root of 5 times square root of 20. So they can be different numbers. Also, you could have something like 3 square root of 2 times 4 square root of 8. This is all multiplication. When you say 3 square root of 2, you're saying 3 times the square root of 2 times 4 times the square root of 8. So it's all being multiplied. So it sort of doesn't matter what order you do it in. I would multiply the terms in front first. 3 times 4 is 12. Square root of 2 times the square root of 8 is the square root of 16. And we know the square root of 16 is exactly 4. So it's 12 times 4, which is 48. Okay, so that's just a review before I show you the FOIL method. I think I can do it here. I'm going to start with 5 times the square root of 3 minus 4 times 5 square root of 3 plus 4. This is, if you didn't notice, is the difference of two squares, but let me work this out. So we're doing the FOIL method. You have a binomial times a binomial. So we have to do the FOIL. We have to do first, outer, inner, last. So when you multiply these first two together, you're getting 5 times 5 is 25. Square root of 3 times the square root of 3 is the square root of 9. So I multiply these two together. Then you do the outer two. So 4 times 5 square root of 3 is 20 square root of 3. 4 times 5 is 20. Then we're doing negative 4 times 5 square root of 3, which is negative 20 square root of 3. And then we have negative 4 times positive 4, which is negative 16. And you can see that these two middle terms cancel each other out, because you have 20 square root of 3 minus 20 square root of 3, so you have nothing left. These two just cancel out. Over here you have 25 times the square root of 9, which is 3. 25 times 3 is 75. Minus 16 is 59. So I ended up with a whole number answer in this case. I'm going to do 3 examples. You don't always get a whole number case. This worked out because it got rid of the middle terms, so it simplified the answer. But in the next 2 examples, that doesn't happen. So here's another one. Square root of 5 plus the square root of 3 times the square root of 5 plus the square root of 3. So this is not the difference of two squares. This one was adding and subtracting. These are both adding. Okay, so first, outer, inner, last. Square root of 5 times the square root of 5 is the square root of 25. Square root of 5 times the square root of 3 is the square root of 15. Square root of 3 times the square root of 5 is also square root of 15. And square root of 3 times the square root of 3 is the square root of 9. So I just multiply 5 times 5, 25. 5 times 3, 15. 3 times 5, 15. 3 times 3 is 9. Square root of 25 is 5. exactly. Square root of 9 is 3. We cannot take the square root of 15, and we cannot take the square root of 15. So now we have 5 plus 3 is 8. Those are whole numbers. And then 1 radical 15 plus 1 radical 15 is 2 radical 15. That's just adding like terms together. And this is my answer. So in this answer, when I did a binomial times a binomial, I ended up with 1 radical and 1 non-radical term. Over here, we just ended up with a whole number. Okay? One more example of that. And then I want to show you one other thing. 4 minus the square root of 5 times 5 minus the square root of 3. We're doing a FOIL method. 4 times 5 is 20. 4 times radical 3, or negative radical 3, is just negative 4 radical 3. I'm just multiplying them together. 5 times radical 5, it's negative here, so negative 5 radical 5. And then square root of negative square root of 5 times negative square root of 3 is positive square root of 15. 3 times 5 is 15. And in this example, I can't reduce the answers at all because I can't add a radical 3 to a radical 5 and a radical 15. They're all different. And as I said at the beginning of the video, you can't add radicals unless they're the same radical. And this is just a whole number. So this is your answer. You can't simplify the answer like you did in the previous 2 examples. Okay? So sometimes you get 4 terms, sometimes you get 2 terms, sometimes you get 1 term. But we're just doing the FOIL method, which we already know how to do, and we're just combining radicals, which we kind of already know how to do too. So that's it for that. I want to show you one other thing. It's rationalizing the denominator that we've already talked about, but this is a little bit different. This is with binomial terms. So if you had 1 minus radical 3 over 5 plus radical 3. So this is just an expression, an algebraic expression, and you wanted to rationalize the denominator. In other words, you don't want to have a radical in the denominator. There's a way to get rid of it. You could multiply by something called the conjugate. Conjugate. So what that is if this is 5 plus radical 3, we can multiply by 5 minus radical 3 and 5 minus radical 3. And this is like multiplying by 1 because you have the same term in the numerator as you do in the denominator. Right? So as long as the top is the same as the bottom, it's like multiplying by 1. So it doesn't change the quantity here. But what's going to happen is in the final answer, you're not going to have a radical in the denominator. So you're going to have to do the FOIL method on top and on the bottom. And that's called rationalizing the denominator. I'll just work this one out. So 1 times 5 is 5. 1 times negative radical 3 is negative radical 3. 5 times negative radical 3 is negative 5 radical 3. And negative times a negative here is going to be a positive, and 3 times 3 is square root of 9. Over, I'll have to reduce that after. Here, this is going to be the difference of 2 squares. So you're going to have 5 times 5 is 25. The middle terms are going to disappear because you're going to have 5 times negative radical 3. 5 times positive radical 3. You can see they cancel each other out. And then radical 3 times radical 3, that's a positive times a negative. Square root of 9. And now I just want to reduce my answer. So in the numerator, I've got a 5 here and a 3 here, because square root of 9 is 3, so 5 and 3 is 8. And then I've got a negative 1 radical 3 and a negative 5 radical 3, so I have a negative 6 radical 3. And in the denominator, I have these two canceled out, and I just have 25 minus 3. Square root of 9 is 3, which is 22. 22, yeah. And that's my final answer. And that's rationalizing the denominator by multiplying by a conjugate.